today also I will be taking a demo, and from Monday we'll start the sessions. May I know, like, who are new to this particular session? You can raise your hands. Kumar, okay, Ram Mohan, anyone else? Okay, Chandrasekhar. Okay, so a few people are new as well. Okay, so I'm conducting a demo once again, and from Monday we'll start the session to make a note.
Also.
Oh, okay, yeah, done. Thank you. So we have enough audience to discuss again with the demo. See, this course is all about multi-cloud. See, multi-cloud in the sense, nowadays organizations are looking at to run their particular applications or anything in different clouds, because if you look at the functionalities of each and every services that are offered by the cloud, few advantages we have in one cloud and other advantages we have in another cloud. Then what organizations are looking at and what the clients are looking at, they want to run their particular applications or a software on a different cloud, and they have to manage together. So I need a people who has exposure to the AWS cloud and Azure cloud. Okay, so that is where we are learning at this particular concept. So let me explain you all the details in a better way. But this course is all about DevSecOps with multi-cloud, and we are focusing on a cloud like AWS and Azure. AWS is nothing but Amazon Web Services, and Azure is from Microsoft. And thus the subtopics, the major topics of this particular program is nothing but Docker and Kubernetes. So we will be running our tools and services more on Docker and Kubernetes. You know by now, or you might have heard about it, most of the organizations are running their applications on containerization technology. So let us see what is that in detail as well. Now, let's go to the next one. So let us see the agenda of this particular demo session. First, I'll be talking about introduction of myself, and then basic IT terminologies. See, though we have some IT knowledge, means we are working professionals, or you might be coming from IT background. See, if we don't know certain terminologies, we are using it, but we don't know what is the purpose of it. So let me talk about them few, and then just a second. What happened? Okay, types of compute platforms, how the technology was evolved. I think I've shared the screen, right? If not, oh,
No, sir, you are not share the screen, sir.
okay, let me share. Let me share. I thought I've shared it. Thank you. Okay, I hope you are able to see now. All right. So, introduction followed by basic IT terminologies and types of compute platforms, means how the technology was evolved. Earlier we have physical machines, after that virtual machines, now we are using a containerization technology. What is it? How the transform was happened? And then introduction to Docker tools. So Docker, we have many tools. Okay, so what are those tools? Why we have to use them? We will discuss about them in detail. And then introduction to Kubernetes orchestration. What is it exactly? Why we have to use it? What is meant by orchestration? We'll talk about that. And then followed by cloud solutions for, just a second guys, someone is calling me, just a second. Yeah, it's okay, I'll leave it. Let me share the screen. Yeah, after this I'll be talking about cloud solutions for containerization. So if I want to implement container solutions in my AWS or Azure cloud, what are the services we have? And then followed by introduction to DevSecOps. What is DevSecOps? What is it exactly? What we have to do? We'll talk about that. How come it is different from DevOps? And then CI/CD process. How to automate the entire life cycle of SDLC. And then automation. If you need to automate in CI/CD pipeline, what are the automation tools we have to learn? Like content management, okay, or configuration management, and then infrastructure as a code tools, and then QA sessions, and then followed by conclusion. Okay, so this is the agenda of this particular demo session. So let's jump into the introduction. See, myself is Sudhams, and I'm working as a cloud architect. So in Visualpath, they call it as Sudhir, kind of alias. Okay. Now, my professional experience is all about 12 plus years, where I worked in IT domain in different technologies like hosting. Hosting industry, I've worked for almost 2.5 years. After that, I jumped into DevOps in 2000, somewhere around 2014 or like that. Okay, I jumped into DevOps technology, and from after that, I shifted to containerization technology with Kubernetes. Okay, so that's where I've been working on this IT industry in different technologies. My focus is more on containerization technology with automations and everything. So I'm holding different certifications. So if you need any help in the certifications like Kubernetes, CKA, CKS, and then Azure certifications like DevOps and administration, AWS certification solution architect, and then OpenStack certification like administrator. Okay, so these are the certifications which I hold as of now. As of now. So if you need any help in this kind of certification, so please let me know. But this is not in the training program. We don't discuss any certification related questions and answers. Now let me talk about few things. As I told you before, to brush up ourselves where we are. Though we are working in IT industry, we might not know some of the terminologies and what is the purpose of it. The first one is nothing but information technology. So does anyone know what is information technology? What is IT? The new guys can answer. Old people who have already listened to this demo, you can skip it. Does anyone know what is IT? Information technology, right? What is all about? Information in the sense which will be stored in the digital form, right? And ones and zeros combination. So information technology is all about the technology which is used to store the data or to transfer the data is called as information technology. Okay. Now, what is meant by desktop? And what is a desktop? Desktop operating system, we call it, right? Any example for it? Any example for a desktop?
All
Your
standalone
Windows
computer.
operating system.
All
Your Windows
standalone.
operating system.
Understood.
Yeah, that is example. Okay, what is a server? You might be seeing your Facebook application. You're accessing Facebook application from your laptop, right? So your laptop is a desktop where the Facebook application got deployed. Okay, that is a server. Okay, server will serve the data. Desktop will what? Will access the data. That's all. So it is like a client. Desktop is like a client. Server is nothing but a who will serve the data. Someone will send a request to the server. Server will respond to that particular request. Okay. Now I'll talk about that in detail. Then what is meant by websites? What is a website? Any
Collection of
example?
web pages.
Collection of web pages. So what you will display in the web page? Some information. That
Information. Yes.
information could be in the form of images, videos, audios, or some content. That is a web page. The web page could have anything, right? Okay, so that is a web page. Combination of these web pages is called as website, like home page, gallery, services, or contact us, or let's say courses, search bar, sign in, sign out. All these are called as web pages. So combination of this web page is called as website. Okay. Now let us see the next terminology called network. What is a network? Why we use a network in daily basis?
I mean, from where the data goes. I mean, from the client and provider. I mean, that where that data moves. I mean, to
Okay.
network pool.
See, even we are using network, right? We are using a network right now to talk to each other. For
Correct.
example, SIM cards and all. If you don't have a SIM cards and all, how we can talk to each other? So physically we have to meet and we have to talk to each other. That's the only solution what we have. Now, if you have a network, you can sit at your home, I can sit at my home, and we can talk to each other. So network is all about connecting the devices, okay, over the internet or over the intranet. Intranet means internally, externally, okay. So that is the purpose of network. And what is a storage? Any example? Storage.
The
Google
database
Drive.
we talk about, like
Google Drive.
Google
Database.
Drive. Your disk,
SSD in
hard
our
disk,
laptop.
floppy,
uh,
Yeah.
yeah,
SSD hard
storage.
disk, HDD hard disk, floppy, pen drive, all this comes under storages to store the data. Okay, so somewhere I have to store the information, right? It could be a RAM, it could be a disk, it could be a Google Drive. Okay, drives, OneDrive, Google Drive. So all these are like solutions to store the data. It could be any format of data, depends upon the storage type what we are using. And then finally we have workloads. Workloads in the sense it could be anything. You can run some application, you will run some software, or you will run some program. You will run any sort of application like database, web server. All this together, the terminology is called as workloads. Okay, so don't get confused. Workload is all about something that you are running on a system. It's called as workloads. So these are like basic information technology terminologies we use on daily basis, but we have to know what is the purpose, what is the background of it. Everybody see, sometimes we will learn the word but we don't know what is the meaning of it. That's what we are trying to understand. So why I'm saying you this one, because we need to learn the basics. That is so important. If you learn the basics right, so you will understand. You can take your own examples to understand the concept. That's what I'm trying to say. If you are good in fundamentals, understanding the next level of concept is will be easy for you. Okay, so that's the reason I have talked about this particular terminologies. And how the computer transformation was happened. If you look at the left hand side picture, the computer was LLA, a big machinery. It should have lot of space. Okay, you can look at that machinery. We need to operate them, we need to know how to operate it. It is too complex to maintain. After that, nowadays what happened? Now we are using a small what is a box. Earlier we used to, 10 years back or 15 years back, we used to use PCs, like a big monitor and with some CPU and then keyboard and all. The problem with that is we cannot carry it anywhere. Since we are doing work from home right now, laptop is the right solution for us. I can carry it in my bag, my traveling bag and all. I can work from anywhere, any geographical location if I have internet connection. So that is a computer transformation which was happened. I hope you know about this. I no need to explain in detail about it. So this was the computer transformation which was happened. Now let us understand what is the basic difference between desktop and server. So let me talk about this in detail. Left hand side is like a desktop, right hand side is nothing but a server. Okay, so server provides services to the client. I will deploy some Facebook application on the right hand side, Facebook application, or let's say Flipkart, Amazon, AHA, Netflix, or something like that. I will deploy them. Okay, so when you're running your application on a server, someone will access your application by using this desktop. Okay, you can see here right now. This is like a desktop. Now in the desktop, I will type facebook.com. My request from the internet, okay, from the network, it will go to this particular server, and server will take this particular request. What are the data you are asking for? It will verify, and then it will give the response. That you will see in your desktop. So server will serve the data to the clients. Okay, while desktop request services from servers. Desktop is only for personal use. Server is for external use. Okay, many people, some millions and billions of people will access your server to serve the data. It can do that job. Desktop cannot handle it. Desktop is only for one person uses. For example, laptops and computers, what you're using, right? It is only for your personal use. That is called as desktop. Server is for external use. Okay, that is a major difference. Next one is nothing but, sorry, you can see servers are designed to handle many requests, some hundreds, millions, and billions of requests, depends upon the capacity of the server. While desktop computers are designed to be used by only one user at a time. That is another basic difference between desktop and server. Okay, next one. Desktop is most of a GUI, server is most of a CLI based. What is GUI full form? Does anyone know? And what is the CLI full form? GUI, CLI.
GUI
Java
is
user
graphical user interface.
interface.
Okay, CLI,
Command line interface.
command line interface. GUI in the sense this one. What do you see? You will have some UI interface to look into that particular data and understand the concept. But in the server, we don't have GUI. For everything, we need to run the commands. Okay, so that is a server based, and this is the desktop based. Okay, have you understood this particular points right now? What is the difference between desktop and server, or any confusion part in this?
I have a question based on what you just said.
Yeah, go ahead.
What
Go ahead.
what about Windows servers? Windows
See, Windows
servers.
servers has a GUI. Yes, we have a GUI. Okay. For example, if you go to Windows servers, Windows Server 2019, 2022, 24, like that, there you'll have a GUI that is specific to Windows operating system. But if, when you compare with Linux operating system or let's say Unix operating system, they don't have GUI. They'll have only CLI based. Okay.
Okay.
When you go with specific operating system. But in generic, we call it as servers as a CLI and desktop as a GUI. Got the point?
Yes.
Yes. Now, let us understand the concept wise, the workflow. Client and server communication. In the client, you will open something. The request over the internet, it will come to this particular server. So it is a request. I'm asking something. My server will see whether you are a valid user or not. It will verify in the backend, because for everything it should not give the data, right? First it will verify. It depends. Okay, after the verification was done, and then it will check for the data. If it is available, that data will be given as a response to the client. That is all about server and client communication. Okay, so this is the basic terminology to understand what is meant by server and what is meant by client. Now let me explain you the what is it, the evolution that was happened in running the missions. Okay, so I'm telling you, right, physical mission, virtual mission, and then containers. Earlier what happened is, forget about virtual mission right now to understand the concept. Earlier we used to have only physical missions, or we can call it as bare metal servers in data centers. In a data centers, or if you want to maintain data center, we used to purchase a physical machines or a bare metal server. The configurations and specifications of these machines will be high. It is not like your computer, personal computer, like 2-core CPU, 4 GB RAM, okay, 1 TB hard disk, okay, 2.5 gigahertz clock speed, like that. That is not the specifications. Here it will have, let us say, 120 GB of RAM, okay, 5 TB of hard disk, okay, 32-core CPU. The configurations will be high. That is all about bare metal servers or a physical machines. And the cost also will be high, obviously, right? When the specifications are increasing, the price and the maintenance also will be high. Earlier what we used to do is, in the traditional environment, we used to create a server, means we used to purchase a server or we used to maintain a server. On that server we used to install operating system. It could be any operating system based on the requirement. After installing the operating system, does anyone know why we have to use an operating system? What is the purpose? Why we have to use an operating system? You are using on daily basis Android, iOS, Windows. We are using these operating systems, right? Why we have to use it?
Uh,
Any specific reason?
to run your applications, to support your applications.
Okay, that is a secondary thing, but yes, it is one of the point. Any other? See, without having operating system, why can't you run your application? Any specific reason? Okay, let me tell you. See, whether you want to run your application, or whether you want to run a software, or whether you want to run a program, or whether you want to run anything else, application, okay, that needs a hardware. It needs to communicate to a hardware like CPU, memory, disk, and other things. It needs to communicate to them. Remember, your hardware can understand only binary language. It cannot understand human readable language or the programs what you're writing. Then what your operating system will do, it will act like a mediator between you, means some X, and your hardware. Because hardware can understand only binary language, ones and zeros combination. So what your operating system will do, operating system will take that information what you have passed, and that will get converted into the binary language, and that will be given to the hardware. Hardware will understand that information, and then it will give a response, and that response will be given to the operating system. Operating system will show you as the desktop or in the terminal, whatever it is. That is a major purpose of using operating system. Other things are secondary, like we can do multitasking, okay, and we can run multiple applications, multiple softwares, multiple what do you say, programs at a time. That is a additional behavior. But the actual purpose is to convert your human readable language into machine level and machine level to the human readable. That is a major purpose. On top of this, now we are deploying some application. It could be anything, any application like database or a web server or cache server or DNS server, anything. Okay. To compromise on the cost, see, maintenance is high. Why? Because if you have multiple bare metal servers, the maintenance will become too complex, and the cost, okay, the billing also will be high for the client to maintain this service. Okay, so the major problem is nothing but this particular server will be used only for single tenant. Single tenant in the sense what? Only one client related applications you will be running on this server. If this particular server is down, all the applications which are running on this server will get affected. That's the reason what people will do. They will run their applications, different applications on different servers. If I need to run different applications on different servers, the cost is getting increased. To purchase one physical server, I'm spending around, let's say, 10 lakhs, for example. If I need to run these many servers individually, how much amount I need to spend? That is increasing my budget. That is crossing beyond my budget, where I don't have sufficient funds to maintain these many servers as a client. Okay, so every client will have a budget limit, right? So you have to run your workloads only in between them, okay, below your budget. Okay, so at that time we have so many challenges to take a backup, to recreate the server. It will take a lot of time. It is a time consuming endeavor in the disaster recovery. So we have cost, maintenance, and problems with the disaster recovery. We have a lot of advantages, but the major concern is disaster recovery, cost, and maintenance. Now to overcome this, they developed a technology called virtualization. They developed a technology called virtualization. In the virtualization, what they will do, by virtualization is a software. It is called as hypervisor. To create a virtualization, we use a hypervisor. So what is hypervisor? Hypervisor is a piece of software which will create a virtual machines on top of physical machine. So technically how it looks, by using this particular software, we will try to create a virtual machine. In the virtual machine, we will install operating system, whatever you want, and then you will run your application. Because of this, what is advantage? On a single physical server, I can create a number of virtual machines and I can run different applications. So my budget is to purchase only one single server and I can run different applications on different machines. Okay, they are running in individual machines, but they are created by a software. That's the reason why it is called as virtual machine. It is not called as physical machine. Okay, I'll tell you about this in detail. That is the next technology what they developed. Earlier we used to run our applications on physical machine. Now we are running our applications on virtual machines. What is the next technology? Before that, let me explain you what is virtualization with hypervisor. Hypervisor is a piece of software which creates virtual servers on top of physical server. As I told you, on a physical server, by using that particular software, we are creating a virtual machines to run. So how many types of hypervisors we have? We have totally two types of hypervisors. One is hardware hypervisor, which can be also called as type 1 hypervisor, and one is called as software hypervisor, which can also be called as type 2 hypervisor. If you look at the diagram, you will understand in a much better way. Hypervisor types. If you look at the left hand side, it is a type 1 hypervisor. What is the basic difference between these two? Let me explain. In the type 1 hypervisor, you will have a physical machine or a bare metal server. On top of this, you will not install any operating system. Directly, you will install hypervisor. So hypervisor will be acting like an operating system, but it is not an operating system. Okay, so you will be running some hypervisor on the physical machine directly. That is called as type 1 hypervisor. What are the best examples for it? VMware ESXi, Zen hypervisor, or Hyper-V for Windows. These are the examples for type 1 hypervisor. We have many other examples, but these are the major ones. Okay, after this virtual hypervisor got installed, by using this hypervisor software, we can create a virtual machines. And you can install application whatever you want with the specific operating system. Okay, that is called as type 1 hypervisor. In the data centers or in the organizations, we use type 1 hypervisor to run our applications. We don't use type 2. Then what is a type 2? What is the purpose of this? In the type 2 hypervisor, you will have a physical server. On top of that, you will install operating system. It could be anything, Windows, Mac, Linux desktop, or anything. You will install the operating system. After installing operating system, then only you will install hypervisor. The hypervisor which needs an operating system is called as type 2 hypervisor. The hypervisor which doesn't need an operating system is called as type 1 hypervisor. A simple terminology or a sentence to remember. Okay, what are the examples for type 2 hypervisor? VMware Workstation. ESXi is different, Workstation is different. Workstation, Oracle VirtualBox. These are the examples for type 2 hypervisor. After this hypervisor got installed, now we can create a virtual machines to install the operating system. The operating system running inside this virtual machine is called as guest operating system. It is called as guest operating system. And this is called as host operating system. Or we can call it as host machine. Host machine, host operating system. Okay. These are the technical terms that you need to remember as part of hypervisor in the virtualization. Do you have any questions in understanding this concept? So at present, we are running our applications in virtual machine before containerization came into picture. Now let me explain what is containers. Why we have to go for containers. Any questions before this? No? Okay. Now let us see what is a container in detail. What are the benefits of the container? We have portability, scalability, shared resources, development, deployment, fault tolerance, and then agility. Let me explain in detail with the diagrammatical representation. Okay. So I'll go back to the paint and I will try to explain the points one by one. So you understood what is physical machine or bare metal server, and you understood what is a virtual machine. Okay. I think Kumar Gupta, you have raised your hands. Any questions to be answered?
Sir,
No? Okay.
on here you will work on Kubernetes Docker on AWS or in
AWS
Azure.
and Azure. AWS, Azure, both of them. See, this is
मतलब
multi-cloud, right?
means managed containers or just or we will install on EC2 or servers.
No. We have to see the services. In AWS, we have ECS, ECR, EKS, right? And in Azure, we
Okay.
have AKS,
Okay, that
ACI,
you will cover.
Web
That you
apps.
will cover.
So we need to discuss about the services, what we have,
Okay, you will cover ECS also.
all of them. Yes. That is a mandate thing, right?
Okay, yeah. Nowadays, what is this? Actually, I am working in Java background, na, so actually we were installing Docker on the system, or we are using ECS now.
No,
Like simple
you're
Docker
asking.
container.
See, if you are a developer, you need to concentrate more on how to install Docker and how to build images. If you are a
Yeah,
developer,
yeah,
your concentration more will be in building your own custom images by writing a Docker file. If you are a DevOps team and doing some operations and all, you need to know about containers, container networking, storage, okay, how to manage the containers, backup, restore, and how to build images and how to automate them. That is your additional responsibilities when you compare with the developers.
so you will be automating using Jenkins.
Yeah, not Jenkins, no. I'll be using AWS pipelines and Azure pipelines.
Okay, okay, fine.
Yeah. They have their own solutions, right? I'll be using them to automate the process.
Okay, because Jenkins is more used to automate.
No,
That is.
that's not the truth. No,
Okay.
it has been used earlier a lot. That's the reason still it is continuing. But if you are working on Azure pipelines, we already have, right, to implement CI/CD. There is no point of going with Jenkins.
So nowadays, how many project uses Jenkins in
That
percentage?
count how I can
How many?
say.
Yes, sir.
Percentage we cannot say it. Percentage we cannot say it. I'm saying you
Oh,
that earlier we don't have this Azure pipelines and all, right? That's the
yeah,
reason why
yeah.
most of the companies have relied on Jenkins, the third-party tools and all. Okay.
Okay.
Now immediately they cannot shift it to Azure, right? Because in Azure
Yeah,
we have to use YAML files, not a
yeah,
DSL.
yeah.
In Jenkins we are using DSL, domain-specific language. So
Yeah,
if you
definitely.
want to convert that into your YAML approach, it will take a lot of time. They might be migrating in the backend as well. This will take some
Yeah,
time.
yeah, yeah.
Okay. Yeah. Now let us understand what is containerization technology. So to explain that, see, if you want to deploy containers, see, container is all about running your application inside it. In a virtual machine, what we will do, we will run our application along with the software, operating system, sorry. Along with the operating system, we will run our applications. What you will do in your physical machine, along with the operating system, we will run our application. So everywhere it is the same requirement, right? Whether you take a physical machine, whether you take a virtual machine, or whether you take a container. The ultimate goal is nothing but along with the operating system, I want to run my application. But how it is getting created or how it is getting deployed is a different concept. Let me explain that. Now, in order to create a containers, either we can pick physical machine or a virtual machine. We can do it on any one of these particular machines. But if you need to create a virtual machines, what we need to have? Physical machine. Without having a physical machine, you can't create a virtual machines. Okay. But in order to create a containers, either I can use a physical or virtual machine. Okay. On top of this, before creating a containers, we have to install operating system. So I need to install some operating system here. It could be anything. There is no dependency. For a containerization technology, we can install any operating system. Okay. Now, let us say, since we are focusing on Linux operating system, let us say we have installed Linux operating system, or let's say Windows. For example, I'm saying. Okay. Now, after installing this Windows or Linux operating system, now we have to install containerization tools. What are the most widely used tools? Let me display them here. So without having operating system, you cannot install these particular tools. All these are dependencies. You can see here. Without having a machine, I cannot install operating system. Without having operating system, I cannot install the tools. What are those? Let us say the most widely used tools are nothing but Docker, Engine, and then Kubernetes. Kubernetes is called as orchestration. Kubernetes orchestration. These two are two different tools, but these two comes under containerization technology. Okay, after installing them, now we can create our containers. Let us imagine like this, containers. Okay, let us say this is one container like C1. Okay, and this is C2, container 2. Try to understand that. This is only for our identification purpose, to understand the concept. C4. So we have created these many containers to run our application inside it. You might be running some application like app1, app2, app3, and let us say app4. So app5 or app3, I forgot. Okay, app3, like this. In this container, you will run your application. Why we are doing this? Why can't we do it in virtual machine? In a virtual machine, inside that you will install operating system, and then you will run your application. The problem with that is nothing but I'll tell you a simple difference, but don't ask me more than this. Why? Because in the actual sessions we'll discuss more. For now, since it is a demo, I just want to give a small introduction like why we are going to the containerization technology. Now, in the virtual machine, if you look at this particular diagram, in a virtual machine, we have to install operating system, and then you need to run your application. If you are trying to install operating system, that operating system will have a lot of services that have to be running in the backend, because that operating system will have a kernel. Okay, and the kernel will have a lot of services that will be running in the backend. To run that services, it will consume some amount of CPU and memory, and the storage space as well. It will consume some amount of memory and CPU. Just a second, please. Just a second. Okay. So on this operating system, you will be running your application. So this operating system will consume some amount of CPU and memory. Because of that, the amount of CPU and memory that is left, that will be used by your application. What's the problem with that? What are the resources you have allocated to this virtual machine? It is not completely used by your application. That is one of the major factor why we are going to the containerization technology. Here what happens is, this container will not have operating system kernel. It will have operating system related libraries and binaries, and application related libraries and binaries. That's all. It doesn't have any kernel. Okay, that is the reason why this container will consume the resources only that is needed by the application. Okay, Because of this, we can run n number of containers when you compare with the virtual machines. For example, on this physical machine, if you can run only 2 virtual machines, but here we can run some 4 or 5 containers. For example, I'm saying, because you are utilizing only few amount of resources, you are allocating only few amount of resources that is needed to the container to run that application. Because of that, there is more amount of CPU and memory that is left, so that I can launch other containers to run my application. That is a major advantages what we have in containerization technology. There are few drawbacks, but when you compare with the advantages, the drawbacks can be ignored. Okay, so we'll discuss about them in detail. Now everybody in the organizations, they are migrating or they are planning to use containerization technology to run their applications, whether it is a small application or a large application. Anything we can run in this container platform. Okay, so this is all about containers. Now, in order to create these containers, we have a tools like Docker Engine and Kubernetes orchestration. Either we will be using, to understand this Docker Engine and Kubernetes, I'll be using AWS and Azure Cloud. So I'll be showing you in AWS Cloud and Azure Cloud. We can call it as Microsoft Azure. Okay, so that's the reason I told you it is a multi-cloud. Now, so these are the benefits of using that containerization technology. We'll talk about that in detail. Next one, what are the container tools we have? I told you Docker Engine, right? This is a diagram for it. But we have Containerd, Podman, and then we
I
have
have one.
Docker, and we have Kubernetes. These are the most widely used container tools.
Yeah, Sudhir, I have a
Here,
question.
Amohan.
That only cloud Kubernetes and both AWS and Azure, or you will teach us on-premise Kubernetes as well?
On-premises Kubernetes as well. On-premises in the sense what? In your local system, how you can practice Kubernetes by
Yeah,
using KubeADM tool. I'll be
yeah.
showing it. So here I'll be covering on-premises as well.
Means you will cover EKS also? EKS.
Yes.
Okay. And application deployment using EKS.
Yes. True. Yes, Srini. Your voice is a bit low. I think you're not in front of the mic. It is far away.
Okay, am I audible now?
Yes, better.
Yeah. Uh, are you covering GCP also as part of this training?
No, we are not covering GCP.
Oh,
Because why we are not covering GCP? Because GCP is not well used by many of the organizations. They are using only for a few requirements like Docker and Kubernetes. That's all. But they're not widely using this particular services on like AWS and Azure. That's the reason we have skipped it.
okay. Actually, I'm looking for GCP also.
GKE is
Mainly,
Yeah, we
more
have a
famous.
separate course for it. Yeah, we have a separate course for it. You can join that particular course training program.
Yeah,
okay.
so the GKE is more famous than this AKS, no?
EKE,
I
EKS.
mean, this Google Kubernetes engine is more widely used now comparatively.
Yeah, now even my company is shifting to GCP, and I heard like some of my colleagues who are working in AWS, soon they are planning to shift to GCP.
See, only few.
Yeah,
Maybe they are one among them. That's all. But GCP is not that widely used.
yeah,
Except
agree.
for Docker and Kubernetes, we can't create so many solutions over there. That's a problem.
Okay. Mhm.
Maybe they are using only for Docker and Kubernetes. That's all. But our program is not about only Docker Kubernetes, right? We need to learn DevOps services as well. That's the reason why I have skipped it. You understood, right?
Okay.
If it is only Docker and Kubernetes, I could have added GCP as well
Mhm.
to understand. That's the
Okay.
reason why I have not added GCP into this training program, and that will take longer time if I need to add these many things.
Hmm.
Okay.
Okay.
If you are looking specific to GCP, and we have other trainer who is teaching on GCP as well, you can talk to Visualpath. Yeah.
Okay. Yeah.
So here we can see these are the most widely used tools. There are many tools. Why I'm not displayed every tool? Because these are the most widely used tools for container technology. Okay, like Podman is also become more popular nowadays. Podman is also one of the tool. And in Kubernetes, there are many platforms I have to create a Kubernetes solution. Like on premises, we have AWS service and we have Azure services. So I'll be discussing all the services which are important for Kubernetes. Okay, I'll list on them one by one after this. And the cloud solutions, what I have and what I will be teaching, you can see the list right now. AWS ECS, AWS ECR, it is a container registry to store the images. And then we'll be talking about EKS, Elastic Kubernetes Service, and then Azure instances, CI, container instances, web app for containers in Azure. These 4 services are related to Azure. This one, web app for containers, and this is container registry, and this is all about AKS, Azure Kubernetes Service, and then kubeadm for on-premises Kubernetes. So these are the services for containers which I am going to cover in cloud, whether you take AWS or Azure. I think this is what you're asking for. I don't know who it is, Gupta or Ram Mohan, someone asked it.
Mine.
Gupta. So these are the services, what I'm going to discuss in Azure and AWS for Kubernetes and Docker.
You are covering EKS also and in
Yes.
AKS. EKS and AKS.
Yes, both of them. You can see the
And
logos,
what
right?
type of applications you will deploy, for Java or Python?
No, different applications like Nginx, Jenkins, okay, and then other service like databases like MySQL, PostgreSQL, those kind of applications I'll be showing, and Node.js. Programming side, I'll be using Node.js.
Okay.
Node.js, React.js.
Sudhir, actually, I just one question. Actually, there is one more course called, I mean, it's not started, like Kubernetes and Docker for multi-cloud. I mean, this one,
No,
you
that
cover
is
both
not at
the
start.
top. Yeah,
No, it
yeah,
is not.
you
It is
cover.
not there. It is winded up. We have winded up. We have winded up.
Oh, okay. I mean, you will
Yeah, that is
cover
fine.
the Kubernetes part totally, or you will go, I mean,
Everything,
here,
everything.
here
I'll
you
show
will
you. See,
cover.
let me complete so that you will come. If your questions are related to the next topic, please hold on. Okay, let me complete all the slides. Okay, if your question is related to this topic, please let me know. Okay, let me complete all the slides. Then you will understand what I'm going to teach. We are in the early stage right now. Okay, so in the part of automation and deployment, see, we'll be learning Helm charts. Why Helm charts are important for us? If you want to deploy some applications on Kubernetes cluster, we can use YAML approach, that is called as manifest, or we have to use Helm charts, which is called as package manager for Kubernetes. So we'll be learning Helm charts. Okay, that is specific to Kubernetes to deploy your applications. That is one of the automation tool. And then we'll be using Ansible as a configuration management. Then I'll be teaching you Terraform, Azure pipelines, okay, and then AWS pipeline as well. We'll be discussing all this particular deployment and automation tools. There is no point of using Jenkins and third party. Azure is having its own pipeline called Azure pipeline. AWS is having its own pipeline called code pipeline. We'll be using them. There is no need of relying on third party tools. It's not necessary. So what kind of automation I will do? One of the CI/CD approach I will tell you as part of DevOps and DevSecOps. You can use it for both of them. See, you will be writing a Docker file. You will understand later what is a Docker file. But to deploy a container on the containerized platforms like Docker and Kubernetes, we need to have an image. To build that particular image, we need to write a Docker file. Imagine this like a program. Okay, to develop a software, we need to write a program, right? After that, you have to compile it. The compiled program only will convert that into a software, technically speaking. Okay, so imagine like that, compare with it. Now, after writing a Docker file and dependency files, we'll push it to the Git. So I'll be teaching you Git as well. And after that, we have to build an image. For that, we need to write some automation. And then we need to log into the registry. Why? Because I need to push the image to the registry. Okay, for that reason, I need to log in. After that, I need to scan the image as part of security. Because if I have any vulnerabilities in that particular image, I need to find out them. I'll tell you later what is vulnerabilities and all. That comes under as part of security in DevOps. And then image push. If the image scan is successful, now I want to push the image to the registry which I've logged in. And then I need to pull the image where I want to deploy it. I will pull the image. After that, I will do the deployment on Docker Engine or Kubernetes platform. It could be on-premises Kubernetes or cloud service. This is one of the simple example to understand the CI/CD approach with DevOps and DevSecOps. If you remove this one, it becomes DevOps. If you add this one, it becomes DevSecOps. What does it mean? In existing DevOps culture, we are adding security as well. So what is a DevOps? Earlier developers and operations teams used different tools. Developer use a different tool to develop the program and compile it. Operations team will use a different tools to run their applications. Now, because of this, what is happening? Developers will tell that my code is working fine in my system, but that is not working in your system. That is your problem. Operations team is saying that that is not our issue, a development issue. So to fill this particular gap, they are using a common tool. So we are finding out and we are using a common tool where developers can use it and your operations team can use it. And we are automating the process. Here the concept is all about not doing any manual step. As a developer, I need to write a program. That program has to be stored in the program files have to be stored in a repository. After the data has been stored in the repository, everything should be automated. Finally, I have to see my application got deployed in the platform. So this everything should be automated. Nothing should be done manually. For that, you have to implement CI/CD pipeline. It could be a DevOps or DevSecOps approach. DevOps and DevSecOps is a culture that is adopted by many of the organizations in the software development lifecycle (SDLC) process. In the software development lifecycle, they have adopted this DevOps culture to automate the process. Now, additionally, they added security as well in the DevOps culture. Okay, so that is a basic terminology to understand what is CI/CD. CI/CD is nothing but continuous integration and continuous delivery or deployment. To do that particular task, we have to automate everything. Automation. In order to implement automation, I need to find out the tools or the solutions, how to implement that. That is your responsibility. Okay, that's where you will do the job. Developers, what they will do, they will write the program and they will push it. That's all. They need to have basic understanding in Git and the containerization technology. That's all. Rest of the things are your responsibilities all about. Okay. Now, after this, we need to understand monitoring tools as well. Because once your application has been deployed, we need to monitor. We cannot leave it as it is. Because sometimes you might be facing some challenges after the application got deployed. For that, we need to find out a monitoring tools like Prometheus and Grafana. Okay, so we will be using Prometheus and Grafana to monitor those services that are running on the containerized platforms. Okay, so these are the pictures. Left hand side is nothing but Prometheus architecture and right hand side is nothing but Grafana. That is a visualization tool where you can see the metrics in a graphical way. Okay, so that you can send your report to your client or your manager or some particular team lead, whatever it is. So they can see the resource utilization on your containerized platforms. Okay, now, and we need to deploy logging tool as well. Under logging and monitoring, this is comes under monitoring. What about logging? We have to deploy ELK, Elasticsearch, Kibana, and FluentD, or we will be using FluentBit, Elasticsearch, Kibana, ELK, or we can call it as EFK. Why? Because we are using FluentD or FluentBit. So that is a logging tool what we are using. Why? Because you'll be deploying your applications on Kubernetes or a Docker. platform. That container will generate some logs. That logs I need to capture by this particular Fluentd or Fluentbit, and that captured data will be given to the Elasticsearch. In the Elasticsearch, it will store the data. But visually, if I need to see it, I have to go for Kibana. So this is the dashboard of the Kibana, where you can see the logs of all your containers and the applications which are running inside it. So this is logging tool, and this is monitoring tool of your metrics. Okay. Now, what are the job opportunities we have with the Kubernetes? This is one of the statistics which I pulled from official website, and you can see the average, see minimum salary in dollars and the maximum salary in the dollars. But I would say you have to take into this consideration only when you have a knowledge. Without having the knowledge, you can't expect the salary, right? See, first of all, you need to have a knowledge in Kubernetes. You can see the rapid growth, how this first happened. Okay, so it all depends upon the person experience and how much amount of knowledge you have. These are the factors you have to take into consideration. Don't look at the statistics and say that yes, we can get a salary of 18 lakhs, 24 lakhs, 30 lakhs and all. Why they will pay you? You have to have a good amount of knowledge, right? If I need to pay something, you need to have more than that. Obviously, company will think in the same way. You have to focus on the syllabus first. You have to learn the topics thoroughly. Then you need to learn about the statistics. But to display the information, I have pulled this particular statistics and I'm showing you. Okay. So these are the job opportunities what we have in the Kubernetes, and this is the salary range what we have in dollars. And what are the major responsibilities of Kubernetes engineer? Either we have to manage, set up the cluster, that is one of the responsibilities, and or deployment or scaling or monitoring or maintenance. It could be different areas. Either you have to do container orchestration, you need to have focus on container orchestration, you need to have good amount of knowledge in architecture, networking, Helm charts, CI/CD pipelines. We are not going to discuss about service mesh, monitoring and logging, security and storage management. You can pick any one of these categories. Everybody will not be working in all the things, right? All the topics. Okay. Though you are working on a Kubernetes topic, Kubernetes in your project, in Kubernetes we have many categories. Some people will be focusing on storage. Some people will be focusing on cluster architecture, how to deploy the cluster, how to secure the cluster. And some people will be working on networking, or some people will be working on Helm charts. Though in the interview they will ask you everything, but you will be working on a specific, a specific topic. That is the reason why I have written here major responsibilities of Kubernetes engineers. Okay, and what are the roles and responsibilities we have? Kubernetes engineer, the titles: Kubernetes engineer, DevOps engineer, cloud engineer, Kubernetes developer, DevSecOps engineer, infrastructure engineer, or cloud and observability engineer. This will be the role. Okay, role in the sense, the designation, what you are going to have in this particular area. Okay, after learning this particular topics, you can search for any one of the role when you're searching in LinkedIn. So I request everyone to create a LinkedIn profiles, because most of the HRs and recruiters are looking at LinkedIn profiles to pull the people. Okay, Naukri and all these are like old style. Okay, and see, these are the job opportunities what we have. They're asking you these kind of requirements. Okay, the job description I'm talking about. You can say excellent oral and written communication, customer management, okay, and then team management, willing to work in shift, ready to take new challenges, to a strong rail and for learning, certified Kubernetes application developer, or good to have. It is not mandate, it is good to have. Certified Kubernetes administrator. Technical skills required: Linux administration, Kubernetes, Docker, and Azure fundamentals. Then what you will do when you got this particular notification in your email, you will apply for this particular job. Okay, so that's what I've pulled some information from Naukri and LinkedIn, and I've displayed here. This is for senior DevOps engineer, KATS, senior DevOps engineer, principal software engineer, KATS. These are the job requirements, what they're asking for different experiences. Okay, some of them have pulled it. Now, What are the certifications you can plan? After this particular training program, you can apply for any one of the certifications if you are interested. I'll help you out. Okay, how to prepare for it? What are the things that you have to focus? But you need to have a strong understanding on Kubernetes. Then you can apply for either certified Kubernetes administrator or certified Kubernetes application developer. Any one of these two certifications you can do. Any one, both are not necessary. Any one of them. So now let me tell you what are the services I'm going to cover in AWS and Azure. Administrative services. In AWS, I'll be covering IAM, EC2, VPC, ELB, EBS, EFS, and S3. These three comes under storage. This one comes under load balancing. This one comes under networking. This one comes under compute. And this one comes under authentication. Okay, and then this three comes under Kubernetes. Sorry, containerization. ECR, Elastic Container Registry, Elastic Container Service, and Elastic Kubernetes Service. And then Certificate Manager, Route 53 for DNS, Secrets Manager for security, CloudWatch for monitoring, CloudTrail for auditing, and then SNS. These are the administrative services what I'm going to cover in AWS. Then what about Azure? I'll be covering Microsoft Entra ID. In AWS it is called as IAM, but in Azure it is called as Microsoft Entra ID. And then I'll be covering virtual machines, nothing but EC2 in AWS. Virtual network, nothing but VPC in AWS. Load balancing, I've written 2 times here. You can remove any one of them. Yeah, I don't know how I written this. Yeah, storage accounts, nothing but EBS, EFS like that. Azure Disk, Azure DNS, Azure Web Apps, Azure Container Instances, Container Registries, Azure Container Apps, Azure Kubernetes Service, Azure Key Vault, and Azure Web Application Firewall. So these are the services which I'm going to cover in AWS and Azure. Any questions?
Sir. Hi, sir.
Yeah.
So AWS Lambda also now.
No, we are not going to cover Lambda.
Okay. Okay, sir.
Subir, actually, I doesn't know what exactly they call. I'm using a hybrid cloud. If I have to do Kubernetes and hybrid cloud, what service? I mean, I have to monitor both. That time, what service you use?
Then we have a common tools. Then you have to rely on third party like Datadog, okay, as some by kind of tools. If you want to monitor both of them, first you need to see what are the services you want to monitor. Let us say, for example, Kubernetes. For example, I'm saying, okay, you are running your Kubernetes on AWS and Azure. Then what we can use? We can use Prometheus and Grafana to monitor the services running on both the clouds. Okay, so there are solutions like that. I'll explain you that as well. Okay.
Subir, Chandrasekhar here.
Yeah. Yeah, Chandra.
I attended the previous session as well in between. Okay. So I want to know what are the prerequisites for this. I mean, to be eligible to apply
We
for
are
this.
starting from scratch. See, I'll be teaching you Linux as well, which are not mentioned. So I'll be teaching Linux
Okay.
and the shell scripting as well. So you no need to focus, even though you're not from IT background, you can still work. You can do this particular course. Why? Because I'm teaching you Linux, and I'll be teaching you shell scripting, and then I'll be teaching you all the services from scratch. Right? It's not like I'm teaching high level. This is from
So
scratch.
I just want you to understand that I am a layman as of now, okay? Because I
Yeah,
don't know
understood.
anything. Okay. So
You
tomorrow
can,
I don't want
without
to
any
have a
hesitation, you can
situation.
join.
Yeah, tomorrow I don't want to have a situation wherein it is said that you can't know this also. Like whatever you're teaching or whatever you're using, I want to know how is it being used. So is it
Exactly.
fine with you for that? Okay.
Yes, exactly. See, everybody can tell what is IAM, but you need to
Yeah.
know where we have to use it, when we have to use it, and where we cannot use it. Means every resource will have a limitation, right? You cannot do more than
Mm-hmm.
this. You need to learn that as well. That's what we are going to
Okay.
learn. It's not for the namesake.
Okay.
I'm not going to just tell
Mm-hmm.
you like what is IAM, that's all done. No, under IAM, we need to learn what is IAM first, where we have to use it, where it fits, in what
Mm-hmm.
conditions have to use, what are the under, see, I've listed only VPC. To be frank, under the VPC I'm going to teach VPC, subnets, route table, peering connection, transit gateway, VPN, and then security
Mm.
group, network ACLs. These many subtopics, which are not listed here.
So
Okay?
tomorrow I will be able to give my examples as an experienced person to my
Yes,
interviewer after this.
that's what.
And what is
You
the
can tell
K8S
something
which you
that you have
wrote
already
on?
done that.
Sorry,
We
sorry,
can
sorry.
tell in such a way that I have done that.
Okay. And what is the K8S which is written in the previous this thing?
Which one?
Previous 22nd, I guess. 22nd.
22nd. This one.
22nd or
Certifications.
23rd, 23rd, 23rd. 21, sorry,
Okay.
21. Okay, it
21.
is 21. Yeah. Principal Software Engineer K8S. What is it?
Yes. Kubernetes. K8S shortcut. Kubernetes shortcut name is K8S.
Oh,
Under
okay,
K,
okay,
between
okay.
K and S, we have 8 characters, right? Shortcut is
Yeah, yeah,
K8S.
understood, understood. Sorry, sorry. Uh,
Yes.
okay, and I have another doubt. Okay, so what? So to my understanding, DevOps is something like development, combination with deployment and all. Is
Yes.
it a right
So
understanding, or
everything
is there
that
anything
see,
else?
from the developer, we have to take the inputs in such a way that he
Hmm.
should not run any manual commands to deploy his code. We have to take,
Okay.
we need to ask him to push the code to the Git. That's the only thing what he has
Hmm.
to do. From there, I need to create
Okay.
a CI/CD pipeline in such a way that that will get tested, that will get built,
Hmm.
and that will get deployed.
Testing, we will be the source, or like
Yes,
any other
testing we
tester
will
would
be
be
doing
there.
here. We'll be using SonarQube. Let me explain that in the next slides.
Hmm.
Okay.
Solar Cube, huh?
SAST and we will be using SAST and SCA as part of testing.
Okay. Hmm.
See, AWS DevOps and Azure DevOps. What I'm going to cover:
Hmm.
AWS code commit, which comes under Git, AWS code build, AWS code deploy, and AWS pipeline. Code pipeline it is called as. So these are the DevOps
Okay.
services which I'm going to cover in AWS. What about
Okay.
Azure? I'll be covering Azure boards, nothing but ticketing tool.
Hmm.
Jira, Kanban we call, right? Similar to that. And then Azure
Hmm.
repos, nothing but Git. So I'm covering two services from Azure and
Okay.
AWS, and Azure pipeline
Hmm.
and Azure artifacts. Repository is different, artifact is different. We'll understand that. Okay. This is DevOps
Okay.
services. So first we'll be learning administrative services, then followed by DevOps services. What about
Hmm.
automation? I'll be covering Terraform, Ansible, and then Helm charts as part of
Okay.
infrastructure management, because I'm managing my
Hmm.
services on Azure and AWS right now. If I need to manage the services on both of them, I need a common tool.
Hmm.
What is a common tool to manage the infrastructure on both the clouds or n number of clouds? Terraform. Terraform is most widely used by many of the organizations. Only on Terraform also we have a job opportunities. We have
Okay.
only on Terraform. And then we have Ansible. Only on Ansible we can't get a jobs, but we need to learn Ansible as an additional tool, which comes under
Okay.
configuration management. As I told you,
Hmm.
Helm chart is a package manager for Kubernetes. If you want to deploy applications on Kubernetes cluster, we have to use Helm charts. That is for sure.
Okay. Understood.
After completing this, I'll be covering security tools and services. What are those? Trivy, which comes under SAST, Kubebench,
Hmm.
platform security, SonarCube, static code analysis, and then check OV, dynamic code analysis. Okay, which
Okay.
I'll be using in Terraform. So this comes under
Uh,
security part.
okay.
After completing all these services, we are going to discuss our live project. It is not for the namesake. It is our live application. Let me show in the browser. Um, this is our Visualpath live application where I will show you how to deploy it. This is our live application. So this application code I cannot show you, but I
Hmm.
will show you how to deploy it by using CI/CD. Code I cannot disclose, right? But as a developer,
Okay.
someone has given me the code which is developed by using React.js, Node.js, and PostgreSQL database. I'll tell you the architecture, how it works, and I'll tell you how to deploy this one. So that this particular
Okay.
experience, you can add it in your resume as a fake experience or whatever it is, as if you have worked on it.
Okay.
This will
So
help you to
React,
fill the gap.
Node.js, and all we would require to
We
learn, or
don't
like.
worry, but we need to know how to run React application. We need to know how to run Node.js application. and we need to know what is
Mhm.
PostgreSQL. Fundamentals we need to learn. I'm not asking you to write a
Okay.
development. You are not a
Mhm.
developer right now to write a code, but you need to understand how
Okay.
to run a React.js application.
Okay.
Few
Understood.
commands we need to learn. That is important for us.
Okay.
You can't say it is a developer responsibility. Few things we need to
Mhm.
learn, though it is a part of development.
Okay. So we
So
will
now
not
with
be
the,
involved in any development of any software or something like that.
but we need to learn. But we
Yeah,
need
we
to
need to
understand
learn.
how the development will be done. After the development will be done, how will you run that? How they will run it? We need to understand that so that we will automate. You understood?
I'm so
You will
sorry,
write a
but I
program.
still okay.
Let's say you
Program
have
is
written the
written.
program. Let's say
Mm-hmm.
program is written. I don't need to know how
Okay.
to write a program, but I need to know how to
Mm.
compile that program.
Compile that program. Okay.
Compile in the sense what? Converting your program into machine level, binary,
Mm-hmm.
compilation. To compile that, what are the tools we have to use or what are the commands we need to run? That we need to learn. Understood, right?
Okay. Got it. Mhm.
So if you want to contact me, this is my information. And further, if you want to understand how I'll be teaching and all, you can go to the YouTube channel called Sudhi DevOps, my YouTube channel, and you can see my way of teaching. And based on that only, you can join the course. It is not a push kind of thing, based on your interest. Okay, so listen to the topics for 2 to 3 days. Understand whether you are able to catch the points what I'm saying and my way of teaching your understanding or not. Then continue with the course. Okay, if you have any further doubts in your career, just ping me on this particular email address and I'll be replying to it. Okay,
Okay.
and this is our
And
website.
you like
Sorry,
Yeah, Shudir, I have one question. Can you go to the
yeah, please.
IAC tools like Terraform,
Which one?
Ansible, Helm? Yeah,
Okay,
25th slide, I think. So in Terraform, are you going to cover modules also? And
modules also,
Ansible with
yes.
roles?
How to write a module, except Terraform Cloud. I'll be covering Terraform CLI. You know
Okay.
Cloud?
Yeah, I'm already using Terraform. That's
Yeah,
why.
so except Terraform Cloud, I'll be covering everything in Terraform CLI, like modules, data source, blocks,
Okay.
meta arguments, state manipulation, modules,
Okay, like kind of
all
Terraform
these.
input, all
Yeah,
those. All
functions,
those.
functions,
Okay. And Ansible, are you going to cover the roles also?
everything,
Ansible.
roles, playbooks,
Okay.
variables, and then import, inheritance, we call it as
Okay.
all this
And
inventory.
hmm, yeah, may I know how
so
long this course you are going to be covering? 2 months, 3 months, approximately.
3 months,
Estimate.
3 months, 3 months.
Okay.
With this syllabus, I have to take 3 months. There is no other choice for me.
Yeah, agree. Because many components, right?
Yeah,
three
because I need
months
to
means
cover
And
it
everything.
will be
Sorry?
it will take around nearly December.
Obviously.
Okay. And just a simple question. Uh, what is I mean, starting package that we could expect after a like normal experience with this in an Indian
So
system?
knowledge, I told you again and
Mhm.
again, it's knowledge. If you don't have a
Yeah,
knowledge,
yes.
you will not even get
Hmm.
a, you will not even get selected. Simple.
Yeah, yes. That's what if we actually interview and with the knowledge which is which is
See,
being
do you have
shared.
any prior experience or you're talking as a fresher?
I have a prior experience of 8 years, but within 2 years of gap in between, like from 2023. So
Hmm.
that's the situation.
Okay, if you add 2 years or 3 years experience, minimum we can expect 8 lakhs, 12 lakhs, 14 lakhs as well. Depends upon the
Okay.
organization budget as well. They'll tell you that for
Okay.
this particular experience with this particular what is a relevant experience and all, they can give you only this amount of package. You cannot go beyond
Okay.
that. There are certain
Hmm.
limitations as well. See, there are
Yeah, yes.
lot of factors. Forget about those
Yeah,
kind of
yes.
things if you're concerned about it.
Mhm. Sorry?
If you're concerned about that, that is not a right one to discuss actually. Salaries, packages, and all these are secondary things. First, we need to
Yeah,
get a
yeah,
good
I
job
understood.
and survive in that.
Yeah, yeah, I got it. That. So just wanted to know. That's it.
Understand? Understood.
Yeah,
That's what
okay.
I've shown
Thank
that
you.
particular slide, right, in Kubernetes.
Mhm.
This
Yeah,
one.
yes.
Only for Kubernetes,
Mm-hmm.
I'm saying. Look at if you have a
Okay.
DevSecOps experience in multi-cloud. Imagine the package.
Okay. Mm.
And Sudhir, I
Okay.
have one question about the course. Like, first you are going to cover Docker and Kubernetes, and you will switch
First,
to the
I'm going to
cloud.
start with Linux basics. Then I'm
Yes.
going to start with AWS and Azure services first of all. Then I will start Docker and Kubernetes in both the platforms. So I'll be covering here and there. You understood?
Okay. Okay. Good.
Then DevOps, then security. Finally, our project.
So in AWS EKS, you are going to spin node group. You are going to create node groups, and
Sorry?
you are going to
Your mic
create
is
node
far
groups.
away.
So in AWS EKS, are you going to create node groups and spin the
Yes,
missions
everything. See, that's
in each?
basic fundamentals, right? Without teaching
Okay.
that, how come I can complete the topic?
Yeah. Yeah. I just wanted to know, like, because I
Workload is
didn't see
nothing but
the
a
course.
compute. So without creating a compute, see, that's what I've told. EKS, that's what we have idea, right? EKS is not about only control plane. We have compute plane as well. That's what I've
Yes.
told. Here I've written only the service name. I have not written the resources name. Under that, we have many resources to discuss.
Yes.
See, here I've not written Fargate. I'll be talking about Fargate as well. Do you know what is Fargate?
No, no, I didn't work
No,
on
right. You know only about node group, but we need to talk about Fargate as well.
that. Hmm.
Example I'm saying.
Yeah.
Sudhir, in terms of, on-premise, you are also said on-premise now because we need to create ingress and all those things while doing that
Yes, we
Kubernetes on
have third-party
on-premise.
tools. Nginx Ingress. We
Yeah,
have Metal LB load balancer. We
I
can use
mean,
third-party services.
yeah, that will be covered or not?
Ingress and all I will not cover. Why? Because if I need to cover on-premises everything, and again AWS, EKS and Azure AKS, it will take longer time. On-premises, why I'm showing you, because to practice yourself in, not in cloud, you can practice everything in your on-premises as well, except that ingress and service type, load balancer, and then CSI, container storage interface. Those you have to practice on cloud, not in your on-premises. Understood what I said?
yeah. So you start with cloud or you start with on-premise first? Kubernetes part.
See, it is not on-premises. I told you only Kubernetes. Rest of the
Yeah.
things are cloud, right? First, I'll be talking with Linux. Without learning Linux operating system, how you can start with cloud, right? So first, I'll be covering Linux, then cloud services, administrative services. After that, I'll be talking about Docker and Kubernetes services, then DevOps, then security, then automation tools. Finally, our live project.
My only question is, AKS we directly have that service. Installation part for Kubernetes on-premise is something like difficult compared to AKS or
Yes, yes. And difficult in the sense you need to know what is happening beyond the scenes. To understand that, on-premises is a better one to understand the topics, the underlying infrastructure.
yeah. So that you will
That's what I
teach
will be
us.
teaching you. That is what I'm saying, Kubedium tool.
Okay.
So by using Kubedium tool, I'm going to teach you how to set up Kubernetes, what are the components we have, what is the architecture, how they work, what is control plane, what is compute plane. We'll be learning that.
Okay.
Then why we will be using Kubedium tool? That's all about learning on premises. Except a few things. What is it? Implementing ingress, implementing CSI, storages and all.
Okay. We will. You will teach project based and all those things. So
Yeah,
these
those
are
are
right.
fundamentals. I'll be teaching them. PV, PVC, storage class, services, secrets, config map. That I'll be teaching everywhere. You can practice in your local system as well by using Kubedium tool. Okay.
Yeah.
Thank you. Thank you all. And from Monday, we'll start the session.
One
with the
last
Linux operating system, and then we will start other services as well, which I've listed in the slides. And these slides, if you want, Visualpath will be giving you as a PDF. You can use it as a reference. Okay.
Sudhir, one last question. Can you hear me?
Yes, please. Yes.
So, how long it gonna take to complete this
3
Linux and
months.
jump into Docker part?
See, that time frame you cannot, I cannot tell you. To be frank, I cannot tell you. I might be taking 5 days or 10 days to complete Linux because it is not about hurry burry to complete the syllabus. According to our understanding, you guys are understanding. Based on that, I will try to modify the syllabus as well. Means I will teach first Linux, then I thought I will. I told you that I will teach you AWS service and all. I might be teaching other services. Depends upon the people how they are responding, right? Based on that.
Okay. Yeah. Thank you.
But I cannot give the framework saying that this syllabus will complete in 5 days, this syllabus will complete in 10 days and all. That time frame I cannot give it. I'm not even giving from 2016 when I started teaching. It is all depends upon the flow, how I teach. Thank you. Thank you all.